Do you feel the vibes?
So we're going to talk about angles from a different mathematical point of view, okay? So we're going to start with array, like you learned in geometry. Remember, array has one endpoint. Now, suppose we clone this ray. Now you have two lying on top of each other. And if you start rotating that second ray, what you have is an angle. This is the ray that you started with. And then if you rotate that second one, what you've created is an angle. Okay, so that's how angles are created. They're basically two rays. And they are joined at the end point. Okay, the starting position, that black ray that we started with, will form the angle's initial position. The initial position, and then once you rotate it, that blue one, like where you stop it, that is called the terminal. Not position, sorry, the terminal side, the initial side and the terminal side. Okay, so just like this one, you have an initial side, you have a terminal side. The point where the two rays meet, that end point, is called a vertex. Okay. All right, so you can have an angle anywhere in space, but in math, we take it and we put it on the coordinate system. When you put it in a coordinate plane, you have an angle in standard position. And when that angle is in standard position, the initial side lies on top of the x-axis, right? And the vertex lies at the origin, right here. All right, so that's an angle in standard position. Now, once you have your initial side fixed on the x-axis, that second ray that you cloned, when you're going to rotate it, you can either rotate it upwards or you can rotate it downwards. But in math, we don't say upward or downward. That's just silly. We say clockwise or counterclockwise. Okay, so not that clock with the numbers, but do you know, like an analog clock, right, with the hands? So which way does a clock go? It moves like towards the right, I guess, right? That way is clockwise. You see that? Like, so there is no, when you say clockwise, there is no discrepancy right or left. The way that the hands move, that's clockwise. And then the direction, thank you, the direction opposite to it is counterclockwise. Okay? So in math and science, counterintuitively, counterclockwise is always the positive direction. Okay, so when the rotation is counterclockwise, we have a positive angle. When the rotation is clockwise, we have a negative angle. Okay, so take a look at this. We started right here, and then we rotated in the counterclockwise direction, and we create an angle that is positive. So for example, this angle will be like positive 200 degrees. Or we start here, we go in the negative direction, okay? And this angle will be, for example, like negative 250 degrees, okay? How exactly we measure, we're gonna have to know. If you want to walk around and get some water or rest or something, you can do that. But if you're in here, I need you to stay with me, okay? All right. So, okay, so here's a summary of angles in standard position. Vertex at the origin, initial side is the positive x-axis, and then the terminal side you obtain by rotating it. Okay, so let's draw some angles in standard position. All right. If I ask you to draw an angle, I need to see three elements to the angle. First, you have to draw something here with an arrow, that's going to be the initial side. Now, we want to draw an angle of 210 degrees. So when I start here, each of these corners is how many degrees? 90. Another 90 is 180, and so on. So you're going to show that you're rotating in the positive direction. A little bit past the 180 is 210. And then you make your terminal side over there. Okay, so this is 210. So if you want full credit, okay, only if you want full credit, you have to show me three things. You have to show me this. Okay, you have to show me this loop with the arrow. You have to have the arrow because I need to know what direction you went. And then you have to show me this third one. Okay? All right, that's only if you want full credit. If you don't, do whatever you want.
So you're kind of just like estimating what they...
Yeah, you're going to eyeball it. Okay. You know, like I'm not going to take a protractor and measure it. But for example, like if you end here, then, you know, we know you're wrong. Okay? Yeah. Right. So negative 40. Again, this is the initial side. Negative 40, we're gonna go in the clockwise direction. So this way. Now, if one corner is 90, exactly halfway is 40, right? So you could just eyeball it that way. So right there, that is negative 40 degrees. Okay? Now, 470. So for 470, I start here. I go around 90, 180, 270, 360, but I need to go more. So let's see, if you have 470, you already went 360. How much more do you have left? 110. So we continue past the 90 to 110 right there. So do you see that spiral? I need to see that spiral. Okay. Coterminal angles are angles that end in the same place. So for example, okay, let's draw an angle of 60 degrees. Okay, here, 60, right there, pretty straightforward. Okay, now let's draw an angle of, I don't know what color to choose. I'll do black. Let's draw an angle of 420. I start here, okay? I go 360. How much more do I need to go? How much? Right. But if I went 360, how many degrees more do I need to make it 420? Another 60. So look at that. Look at where I ended up. I ended up at the same place. Now, they're very different angles. One is 60, one is 420, but they start and end at the same place. So those two are called coterminal angles. Okay? Now, if you're at a point, how many degrees do you have to go around to get back to the same point? 360. And do you have to go 360 in a specific direction, or can you go in both directions to get both directions? So, to find an angle that is coterminal with another angle, you have to add or subtract any multiple of 360. So you can add 360, you can add 360, you can add 360 again and again and again, and you can get an infinite number of coterminal angles. Okay? So, for each angle below, let's find one positive and one negative angle that is coterminal with the given angle. Okay, so for the positive one, we're going to take 210 and we're going to add 360, and we're going to get 570 degrees. That's it. For the negative one, we're going to take the 210, we're going to subtract 360. How much are we going to get? Negative 150 degrees. Okay? Now, this is an important piece that a lot of students miss. When we say negative coterminal angle, it legit has to be a negative angle, right? It has to have a negative sign. So, just because you subtracted to get an angle, it doesn't mean that it's a negative coterminal angle.
You have to subtract until
until you get negative. So for example, if you had like 560 and you subtract 360, what do you get? 200. That's a positive one. So you have to keep going until you get, okay? Cool. Okay, so here, negative 120. For the positive one, I get negative 20 plus 360. So I get 240. For the negative one, negative 120 minus 360, negative 480. Cool? Yep. Okay. All right. Let's talk about units. Right. So just like anything else that we measure, we have multiple units for angles as well. So for example, like if you measure, distance, right? You can say, okay, this is like, 30 feet. Or you can say it's like, 300 centimeters, right? Those are different units to measure something. Or like, it's 70 degrees. Oh no, it's 20 Celsius, right? Okay, so angles also have multiple ways to measure. One is you can measure angles in degrees. And another way to measure angle is radian. Okay. So let's talk about these for a minute. First, let's talk about what degrees are. Let's just get, an idea of what we're talking about. So, how many degrees are in a full circle? That's a good circle. I can draw very good circles. Yes, thank you. So 360 degrees, right? So imagine you had a perfectly circular pizza. Now, normally when you order pizza, they cut it into 8 or 10 slices. So imagine you tell, like you call up Domino's and you're like, hey, I'd like one large pizza. Please make it like perfectly circular. And oh yeah, can you please cut it into 360 slices, right? So just visualize that for a minute. 360 slices. So each slice, right? How big would it be?
1 degree.
1 degree. I mean, it would be like a tiny sliver of pizza, but it would be the equivalent of 1 degree. So like, if you had like this much, you'd be like, oh my God, I ate like 20 degrees of pizza, right? Right? So can you imagine like what a thin sliver 1 degree is, right? Okay. So moving along, let's talk about another situation. Now, suppose we build a track, for like track and field. Suppose we build a track, but like, a math teacher is in charge of it. So it's perfectly circular. They're like, we don't want this oval business. It's perfectly circular. So now we have a perfectly circular track. Okay. So suppose, you do that and then, your coach is like, okay, we're going to measure the radius of this track. And it happens to be 10 meters. The radius is 10 meters. Okay. Now, suppose this is you, right? And you're like, I don't know, in like PE class or something. And the coach is like, all right, we're going to walk around the track. Okay. So, you've got your like watch and everything, and you're like tracking your steps. So you start walking. You're like, okay, good. I could get some steps in. You start walking, right? And then, the coach like, blows the whistle, makes everybody stop. Okay. You stop there, you look at your watch, and you're like, oh my God, I've walked a length of 10 meters, right? You look back, you're here now. You look back at the center and you're like, oh my God, that's where the center of the track is. Oh, look. Okay, do you see how you've created an angle from where you were to where you are now? Okay, so this is the distance that you walked, right? The distance of the radius is how much? 10 meters. So what if we wanted to do a ratio between the distance that you walked and the radius? So how much have you walked? 10 meters. How much is the radius? 10 meters. What's that ratio? 10 to 10, which is 1. It's 1, right? So that angle that you created is 1 radian. Okay? That's 1 radian. Now, you continue, right? Your coach is like, all right, just keep walking. Never mind, nothing to see here, right? So now he blows the whistle again, and now you're here. And you look at your speedometer or your watch, and you're like, oh my God, I've walked 20 meters. So now the distance that you walked over the radius, how much is it now? 20 to 10, how much is that? 2. So that angle is 2 radian. Okay? So you keep walking, and your coach blows the whistle again, and you're like, oh my God, I've only walked 30 minutes. Like, just let me walk, or 30 meters, right? So let's do the ratio again. 30 meters is how much you walked. What's the radius? 10 meters. So that's a ratio of 3. Ooh. How many radian is that angle now? 3 radian. Okay, you keep walking a little bit more, like you take like literally like a couple more steps, and like he blows the whistle again. Stop. You're like, oh my God. So now you've walked 31.4 meters. So let's do that now. 31.4 over the radius of 10. How much is that? 3.14. What is it? That's pi. Oh my God. Okay. I'm yelling. How much of the circle have you covered? Half of the circle. How many degrees have you covered? 180. How many radian have you covered? 3.14 or pi, right? So this is pi. You've covered 180 degrees, which means 180 degrees is the same as pi. And that is how you shall remember. Isn't that cool? Now, when you walk the entire circle, how many radian is that? Or how many pi? 2 pi. Do you see that? Do you see where it comes from? So that's radian. So 1 degree, very, very tiny. 1 radian, much bigger. So 1 radian, 2 radian, 3 radian, 4, 5, 6. It's 6.28 radian total. Okay? Isn't that cool? So now this is what you remember and you take with you wherever you go. That 180 degrees and pi are the same. Okay. Whew. And just like that, 360 and 2 pi are the same. So we are going to use that, okay, to convert angles from radian to degrees and from degrees to radian. So to convert, if you want to go from degrees to radian, you multiply by pi over 180. Radian to degrees, 180 over pi. But that's not what I want you to memorize. What I want you to memorize is this. Okay? 180 and pi are the same. Now we're going to fill in that little box. Okay? All right. So let's go here. We want to write the following in radian. So we are given degrees. What you want to do anytime you want to convert units, times and a fraction bar. What are we given? Degrees. That means in my fraction, the degrees has to go on the bottom to cancel out. So the relationship is 180 degrees and pi are the same. Okay? So if degrees is on top here, it goes on the bottom here. And pi goes on top. So now, go ahead and put that into your calculator, but you want to get a fraction. So you know what you're going to put in your calculator? Just 135 over 180. Right. So just 135 over 180, and you want to make sure you want to get a fraction. Not the pi. Leave the pi alone. 3/4. So this will be 3 pi over 4. Okay? Next, 270 degrees, negative 270 degrees times. Degrees is on top, it goes on the bottom here. So pi has to go here. So negative 270 over 180, how much is it? Negative 3 over 2, and you tack on the pi. Okay. Okay. Next, we want to go the opposite direction. Radian to degrees. So times fraction bar. This time, what do we have on top? Do we have degrees on top? Yeah. Right. So here, pi is on top. So I have to put pi on the bottom in order for them to cancel out. So pi goes on the bottom, 180 goes on top. Okay, now take a look at what happens here. Pi, go away. So I have negative 2/3 times 180. Right, so negative 2/3 times 180. Make sure you get like the parentheses and stuff right, okay? So negative 120 degrees. Okay, here, times fraction bar. I have pi over here. That means pi has to go on the bottom. 180 goes on top. What do we get? 485? 495. Okay? Right, because it's 45 degrees. Okay? Cool? Okay. All right, let's move on. We got just one more thing. Now, let's go back to coterminal angles. What did we say about coterminal angles? To get from one angle back to the same position, you have to go a full circle. So in degrees, a full circle was 360 degrees. So you have to add or subtract 360. But in radian, what's the same as 360? 2 pi. So I stopped here, like I kind of, didn't continue. But in radian, you have to add or subtract 2 pi. So in degrees, you add or subtract 360. In radian, 2 pi. Okay, so why don't we go ahead and do that here? So here, I have, for the positive one, I'm going to do 2 pi over 3 plus 2 pi. Okay, and you're going to do this with your calculator, right? So again, ignore the pi's. So we're just going to do 2 over 3 plus 2. How much? 8 over 3. Oops. But it's with a pi. 8 pi over 3. Okay? So next, for the negative one, 2 pi over 3 minus 2 pi, right? So we're going to do 2 over 3. Okay, I don't know what's going on with my calculator today. Got it. I just want to show you guys, but you guys are okay doing it, right? Yeah. Okay. So minus, what is it? Negative 4 pi over 3. Okay. Okay, next. So for the positive one, negative 9 pi over 4 plus 2 pi. You put it in your calculator, what do you get? No. No. Negative 9 pi over 4. Okay, you get negative pi over 4. Now, is that a positive number? No. So you have to go again, right? So you have to do negative pi over 4 plus 2 pi. So you do it on the calculator. So you do negative 9 over 4. Yeah, so hang on. So you do negative 9 over 4 plus 2. You get negative 1 over 4. Now you're going to do plus 2 again, and you get 7 over 4. So now this is going to be 7 pi over 4. So take a look. This is the positive coterminal angle. Now, for the negative coterminal angle, look up here for a minute. For the negative coterminal angle, you can take this and do negative 2 pi, but you don't have to, because on the way to getting here, you already got a negative answer. So you can just take that and say negative pi over 4. Okay? Oh my gosh. All right? So that's how we do coterminal angles. Okay, questions? All right, so we're going to stop here.
Press start.